So when you're talking about financial maths, you always notice that financial maths is a broad topic. There's minor subtopics there that you have covered in grade 11, and then there's some that you have covered now in currently grade 12, right? Now, because of that, I've decided to actually create a financial maths series where I break it down into each and every part so that I can help you prepare for the trial. And then if you're doing grade 11, you can actually get, benefit from this one, because we're going to be starting back from grade 11, then get into grade 12, right? So now here, our first video, which is the part 1, it is going to be the one that we talk about compound interest. Now, this is grade 11 work, but then I share it there, so that way you can be able to see the difference between the grade 11 work and the grade 12 work. So let's go ahead and start off with the first one. So here we talk about compound interest. Now I'm going to read the instruction, then show you how to solve that one, and then show you how to solve the second one. All right. Now let's start with the first one. Now the question says here, at what interest rate compounded quarterly must 25,000 be invested in order to grow to 40,000 in 5 years time? All right. So now here we're saying here that this person wants to understand that if they put in initially 25,000, right, and then that in 25,000 after 5 years it becomes 40,000. Notice what I'm doing right here. Before it was 25,000, but then after it is 5,000, right? And then in 5 years' time, right? Compounded quarterly, right? Compounded quarterly, right? What will be the interest? So that's the question, right? So that is the question right here. So the first thing that you must always understand is, how does the formula work? Okay. So now let's first write the formula. So the formula here, it is A equals to, I'm just going to write it right there, A equals to P into 1 plus I into N. All right. So in this formula, there are two things that people, they always tend to make mistake on, right? The first one, it is I, and then the second one, it is N, right? Now, a lot of people, they like to say N is a number of years. N is not a number of years, right? Please understand this. N is not a number of years, but it is the number of time at which the interest has been applied on that period, which is in this case 5 years' time, right? So now here, this then means if you're saying this is not N, now this is not number of years, now how do we basically calculate N? Now we calculate N, right? We calculate N by taking the number of years, right, and multiply this with the number of times the interest was charged in a year, or in other words, the compound, which is, in this case, it is 4. Now, this means now to get N here, it will be 5 multiplied by 4, which is going to be 20. Now, what about I? Now, I here, I is always charged, or you always given I, right, in a year, in a year scenario, right? Or it is always compounded per annum. But then now, once you are told that it is then compounded quarterly, it means now to get your actual I, you need to then take that I and divide it by the compound that you're given, which is where it will then tell you how much you're being charged per quarter, right? That's what we have in this case, right? So this means now that we have all of that, to then calculate I, what we need to do is to first isolate I. So let's go ahead and do that. So the first thing I'm going to do, I'm going to divide by P both sides. Let me get back my pen, color. Then that way this cancels with that. Then I'll have A over P. Here, A over P equals to 1 plus I into N. And then from here, I'm going to put the nth root. Let me see if I can do that here. There we go. Nth root, and then nth root. Now this means now we're left with n root of A over P as equals to 1 plus I. All right. Then now from here, we take this across, the 1 across, and then we have A over P minus 1 equals to I, right? Now, remember, I is I over N, right? So which means now to write all of this in a simple way, we'll then take this nth root of A over P minus 1 and then change our I. Now notice I'm going to use a different color so that you can understand what is happening here. And then write it. Okay, this is brighter. Let's use a much more darker. So I'm changing this to I over M because I want to get the actual I that I'm being asked, because this is the I that I'm being asked, but then this is the one that you get from the formula. So now to get that I, I'll then have to multiply this M into this whole thing here. Now when I do that, then my final formula, it becomes m times nth root of a over p minus 1 is equals to I. Now this helps me very much because now I only get to press calculator once. Now I know a lot of people, they like to actually do it step by step, but for me this works very well. Therefore, now to calculate I, all I have to do is to substitute m, which is 4, multiplied by, and then n is 20, and then square root a, it is 40,000, and then here p, it is 25,000, and then I say minus 1, and then I just press this in a calculator. So going through the calculator, so I'll write it exactly how I'll type it right exactly how I wrote it there. So here I need to find the square root, so I'll press shift and press that so that it gives me that space there to put 20, and then I write 40,000, divide this by 25,000, and then I will minus this by 1, and then that's how I get my value. But then now this is not the actual value, right? Which means now whatever that I get here, I need to times it by 100, right? So now I'll multiply this by 100. So now this is what I get. Now notice that you only get to multiply by 100 after you have pressed this in your calculator. So I'm just gonna close this and then say multiply by 100. Do you need to include this part? Yes, you also need to include this part. But because of I don't have space here, I figured let me just put it in there and then write the final answer there. Alright, so the answer here it is going to be 9.51%. So it will be 9.51%. Alright, so let's go ahead and look into the second question. Now the second question here, it says how long it will take for a value of an investment to treble if the interest is calculated at 22% per annum compounded semi-annually. Alright, so now here you put in an investment in this question. So the question here it says you want to decide to put in investment. So let's say you put X amount of money, then that money after a certain amount of time it triples itself, so which means it's 3x now. Now this is compounded semi-annually, which is going to be 2, and then now the interest of that will then be 22% divide by 2. Then now the question is how long will it take for the value of this investment to treble? So which means now n equals to years. That's what we want to find, years multiplied by m. Alright, that's what we want to find. Okay, so now same applies here. First thing first, we're going to write the formula p into 1 plus I into n, and then we're going to solve for n. Now n here, to get it, we start by dividing by p, and then we have a over p equals to 1 plus I into n. Now to get n is an exponential, so which means I'm going to apply logs. So I'm going to say n is equals to log base 1 plus I into a over p. Alright, then now from here, you might think that we are done here, but remember it said how long it will take. So it means they basically want to know the number of years, right? So which means now here we then change this n into what? Into years, right, by n, right? Now this is then equals to log base 1 plus I into a over p. Again, remember, like I said earlier, the only reason why I'm doing it this way is because I just want to press in the calculator once. So now here I'm going to divide this by m and divide this by m. That way I'm left with years. So now the years will then be that formula, right? Log base 1 plus I into a over p over m. And then now let's go ahead and calculate this. So all I have to do now is just to substitute. So which is in this case I have 22% over 2 into a, it is 3x, and then p, it is x. Now these two, they will cancel, leaving 3 over 1 there, which is the same as 3. but then now this will then be divided by 2. Now getting into a calculator, we're just going to press as it is. So log 1 plus 22% over 2, and then we say 3 over 1. Remember, we have already cancelled those x. Then we divide this by 2, and then this becomes our answer. So let me just open space here. So this means the years, it is equals to 5,5,26 5,263,569 3569. Let me just double check the 027. All right, now the first value here, it tells you that it is exactly 5 years, right? So this is 5 years, but then this decimal here, it tells us that it is something less than that. Now to get the number of months, now this is months because it is in decimal. Everything that we did now, we're calculating in years. Now to calculate this in months, this is what we're going to do. So because these are months, right? I'm going to write this months. Now how do you get those months? So basically all we have to do here is to take this 0.26359027, right? And then we divide it by the total number of a year, which is 1, and then we multiply it by the total number of months because we're converting years to months, right? So now we're going to get those 3 months there, right? So that is how we get our value there. So if you want to then write the value, so it will be 3 months. So we will then say, therefore, 5 years and 3 months. And that is going to be our answer. And that is the first part of our series. Now into the next part, we're going to be talking about effective and nominal interest. And I'm going to see you onto that one. Cheers.